5 is solving exponential equations, and basically what that means is the variable that you're going to be solving for is actually in the exponent. So it might look something like this. So for example, if we have 2 raised to the x plus 2 equals 2 raised to the 5th. So you can see the variable that you're going to be solving for is actually in the exponent. So what you can do, and these first ones are actually going to be much easier because they have the same base. So do you see how if these are both 2's, if these have the exact same base, if those are the same, then all you have to do is take the exponent and make it equal each other. So x plus 2 is the exponent on the left side. 5 is the exponent on the other side. You can kind of just take those out, and then all you have to do is solve. Minus 2, so x has to be 3. So if they have the same base, you just set the exponents equal to each other. So example 1, if we have something like this, 3x plus 1 equals 3 to the 5th. You can see your bases are the same, 3 and 3. So all you have to do is take your exponents. X plus 1 equals 5, minus 1, x equals 4. The next example looks a little bit trickier, but it's actually not too difficult. 6 equals 6 raised to the 2x minus 3. Well, again, they have the same bases, but it appears over here that this one doesn't have an exponent. Give it 1. So you can see now 1 equals 2x minus 3. You're just pulling out the exponent. So plus 3, 4 equals 2x, divide by 2, x equals 2. So that variable right there has to be a 2. The last kind with bases the same might look something like this. 10 to the 3x equals 10 raised to the 2x plus 3. So again, you can see you have the same bases, but now we just happen to have variables on both sides. So you still do the exact same thing, but get your variables together first. So I'm going to undo the 2x to scoot it over here with these 3x's. 1x equals 3. Divide by 1, x equals 3. So these would both have to be 3's. Okay, so sometimes the bases are not going to be the same. So if they are different, we are going to try and make them the same so that we can use the same rule. It's not always possible, but the ones that you guys are going to have to do will always be possible. On the ones that aren't possible, we could use a graphing calculator to figure them out. But again, the ones that you're going to have to do are all going to be possible. So for example, if we have something like this, 5 to the x equals 125. Well, clearly, those are not the same bases, and you could probably guess and check that on a calculator until you figure it out. But what you can do is figure out how could you write that as 5 raised to the something. Because if you can do that, then you can just set the equations equal to each other. So 5 raised to the what to get to 125, it's going to be a 3. Well, if now we have 5 raised to the x equals 5 raised to the third, then all you have to do is pull out this, and you already have the answer. X equals 3. Again, many of you would have probably just guessed and checked that. Another example might be something like this. 4 raised to the x equals 2x minus 3. So how do you get these bases the same? We have to figure out and try how could we make this 4 into 2's, because you always want to go to the smaller of the variable. I'm not the variable, but the base. So how could I write 4 as 2's? Well, we could write 2 squared. See how this 4 still means 4. 2 squared is still 4, but now this 2 squared represents the 4, and we can't forget this x that still comes along with it. Well, now we have the same bases. And now all I have to do is just distribute those. So I have 2 to the 2x equals 2x minus 3. So again, same base, same base. So now set this equal to this. So I'll go ahead and solve this real quick, and then I'll do another one. X minus 3, I've got x's on both sides, so minus x minus x. Looks like I've got 1x equals negative 3, so x has to be negative 3. So let's do one more of those kind. Okay, so let's try this one. So looking at 9 and 27. Okay, so most of you are going to think like, okay, let's turn 9 into 27. Well, you can't actually do that because you have to use powers. So what we could do is we could change these both into 3s. So how do you make a 9 and a 27 but using powers of 3s? Well, for the 9, we need 3 squared. Do you see how that equals 9? And then I'm going to go ahead and just put the rest of this stuff on here that was already on here. Okay, so now 27. How do you make 27 as 3s? 3 to the 3rd power. So 3 times 3 times 3, that's 27. And then I just have to give it to the x. So bases are the same, and now you do have to distribute this. Don't forget to distribute that, so you give it to all of it. So 2x plus 4 equals 3x. And then you could just keep solving. Minus 2x, minus 2x. Let's see, 4 equals 1x divided by 1 divided by 1. X equals 4. So a lot of this is just, it just takes some practice and knowing your powers. Get out a calculator and just start multiplying if you're unsure. Let's do one more of those. Let's do 4 to the 3x equals 8 to the x plus 1. So again, you might think like, well, how can I turn 4 into an 8? Well, once you square 4, it's already too big. So again, I'm going to change both of these into 2's. Write them as powers of 2's. So how do you write 4 as a power of 2? 2 squared. And then don't forget, you still have a 3x here you haven't used. Well, how do you write 8 as a power of 2's? 2 times 2 times 2. So 2 to the 3rd power, but then you have this x plus 1. So again, it's kind of just you figuring out first, okay, see how this still equals the 4, and this still equals the 8, but you just made it into bases that are like, so now it's much easier. So now again, you still have to distribute this stuff. So distribute, so it'll be 2, let's see, 6x, and 3 times 3, let's go 2, 3x plus 3. So again, same base, but now you can set your powers. 6x equals 3x plus 3. And then just go ahead and solve. Okay, so the last thing you might see is if you have a fractional base. So for example, if you have like 1/2 to the x equals 4. Well, remember, the only way that these can become in fractions is if it was a negative to start with. So a 1/2 really means a 2 to the negative 1. So I'm going to change this 1/2 to a 2 to the negative 1, squeeze it with an x, and then how do you make 4 into 2's? 2 squared. And now, again, you can just set your bases to each other, or set your exponents to each other because you have the same base. Negative 1x equals 2 from this right here, and this right here, divide by negative 1, divide by negative 1, and x equals negative 2. So let's do another one of those. Okay, so another one. So we've got 4 raised to the x plus 1, and then a 1/64. So I'm going to use what I have to start with and see if I can turn 64 into a power of 4's. So if we do, let's see, 4 times 4, 4 times 4 times 4 should work. So 4 to the 3rd. So again, this 1 over 4 to the 3rd really means 4 to the negative 3rd. So 4 to the negative 3rd, because that's how the 64 got to the bottom, is you flipped it, equals 4x plus 1. Then bases are the same, so x plus 1 equals negative 3. Minus 1, x equals negative 4.